Hello everybody. This is your first video on angles in circles. So this one's going to look a little bit different because I don't have slides for you on this one. I'm just going to go through some examples for you and draw out what these relationships look like for these different types of angles. So this video is going to focus just on central and inscribed angles, the first four parts of this graphic organizer here, and then you're going to see another video that focuses on these last three here. Right? So let's go ahead and jump into it and talk about it. Okay, so the first type of angle that we need to talk about is called a central angle. Okay, so I'm going to draw an example for you of what a central angle looks like. Okay, so a central angle is just any angle that goes from the center of the circle out to the edge of the circle, and it's always made by two radii. Okay, so what you see drawn in blue there is the actual angle, and then what I'm tracing very badly in pink right here is called the intercepted arc. Okay, so think of it almost like a slice of pizza, right? Where the blue lines that you see, the radii, are like the edge of your slice of pizza, the central angle is like the tip of your slice of pizza, and then the intercepted arc is like the crust of your pizza. Okay, usually this intercepted arc is a minor arc, okay, meaning that it takes up less than half of the circumference of the circle. Okay, so that the rule with central angles is that the angle measurement is equal to the arc measurement. Okay, so I'm going to do an example for you here in a second where you can kind of see what I mean by that and what that looks like. Okay, and then as we know, there's 360 degrees total in a circle. So if I wanted to know the major arc, which is like here outlined in green, again, very badly because I'm having to trace here, if I wanted to figure out how many degrees that was, I would do 360 degrees minus either the intercepted arc, which is equal to the angle. So we write it as 360 minus the angle. Okay, so I'm going to do a couple of examples for you. Let me attempt to draw a straight line down the middle here. Okay, so my first example, here's my circle. Okay, and then here's my center point. I'm going to have a line through like this and a line through like this. Okay, and then I'm going to tell you that this angle right here is 110 degrees. Okay, and then I'm trying to find, I'm going to say this from here to here is X. Okay, and then this from here to here is Y. So we have to find X and Y. Okay, X is pretty simple, right? It's equal to the angle measurement, right? So the angle is 110 degrees. So that means the arc, its intercepted arc, is also 110 degrees. Okay, and then Y is the major arc surrounding that. So that means Y has to be 360 minus 110, which is 250 degrees. When I should have written my answers with little degree symbols next to them. Okay, because we're talking about how many degrees that arc is. So not necessarily how long it is in like feet or inches, right? We're just talking about how many degrees it takes up in the circle. Okay. All right, so let's look at and do another example here. Okay, so here we have another circle. Okay, and then I have this, so I'm going to say this is X, so the angle is X, but I'm going to tell you that this from here to here is 60 degrees, and then I'm going to tell you that, this, right, the other part of the circle is 2Y plus 50. Okay, so again, X is pretty simple, right, because the arc is 60, then that means the angle must also be 60. Okay, But y is a little bit trickier. So I know for sure that the degree measurement for this major arc has to be 300, right? So the arc is 360 minus 60, which is 300. Okay, so what that means is that 2y plus 50 has to equal 300. So 300 equals 2y plus 50. Now I'm writing a little bit too big to go through and actually solve this whole thing. I probably should have zoomed in a little bit more, and I might for a little bit later in this video. But what I would do is I would subtract 50 from both sides, and then I would divide both sides by 2. So in doing that, in doing those steps, I get that y is equal to 125. Okay, so that's central angles. The key thing to remember is that the angle measurement, or the degree measurement, is equal to its intercepted arc measurement. Okay, all right, and that's the key. Okay, so give me just a second. I'm going to clear this off and try to zoom in a little bit more so that I have a little bit more space to write. So give me one sec. I'm going to pause this and I'll see you in just a second. Okay, hopefully this will be a little bit easier to write on, and I'll have a little bit more space here. Okay, so let's talk about inscribed angles. Okay, so inscribed angles are a little bit different than central angles. Okay, so where central angles start from the center, inscribed angles occur on the circumference of the circle. Okay, and they still have an intercepted arc. Okay, so my inscribed angle here, I'm writing in blue. Okay, and then my arc is here in pink. So this still is my intercepted arc. Here in pink. Okay, it's like those videos that you see where people like to slice pies and pizza and cake really wrong. This is what that reminds me of. Another way I kind of like to think about this is you can almost think of the circle as like a wall, maybe with a light on it, and the light is like shining out and hitting something. So the beam of the light is the blue angle, and then what the light hits is the intercepted arc. Okay, so the rule for inscribed angles and their arcs is that the angle is actually less than the arc measurement. Okay, which I'm hoping just from looking at the image kind of makes sense. The angle here is pretty small. I would say that that's maybe like 60 degrees if I'm guesstimating, somewhere around there. Okay, but the arc that it intercepts definitely takes up more of the circle than 60 degrees, right? That almost looks like a third of the circle that's taken up with that intercepted arc. Okay, so if you want to know the inscribed angle or the intercepted arc, the key equation is here, that if you take the angle and you multiply it by 2, that will give you the intercepted arc. Okay, so the arc is double the measure of the angle. Okay, and likewise, if you're going backwards, so say you know what the arc is and you want to know what the angle is, then you take the arc and you cut it in half to get the angle. Okay, so a good general rule of thumb here is written out for you right here, that if you're going from the arc to the angle, you're going to divide by 2. Okay, and if you're going from the angle to the arc, you're going to have to multiply by 2. Okay, because going from the angle to the arc, you have to get bigger. If you're going from the arc to the angle, you have to get smaller. Okay, so let me go ahead and, again, I've got 2 examples for you. Okay, so let me draw a circle here. Obviously, this is a very rough circle. Okay, but here's my intercepted arc and my angle. So I'm going to tell you this angle is 80 degrees, and I want to know what this is. So that's x. Okay, well, x is the arc and 80 is the angle. So my rule is I do 2 times the angle, which is 80, has to equal the arc, which is x. So that means my angle or my arc, excuse me, is 160 degrees. Okay, it really is that simple. Don't make it more complicated than that. Okay, then going backwards, going the other direction. So let's say you have a circle. Again, very badly drawn by me. Okay, but here's my angle on my arc. I'm going to say I don't know the angle, but I know that the arc is 66 degrees. Okay, so again, the rule is that if you do 2 times the angle has to equal the arc. Okay, so in order to solve this, I would divide by 2 and get that x is equal to 33 degrees. Okay, you can also do that a little bit more directly with this second formula right here, where you start with the angle by itself, rather by itself on the right side of the equal sign, rather than the arc being by itself on the right side of the equal sign, right? You could also do this by just doing, okay, 1/2 times the arc, which is 66, has to give you the angle, right? But you'll end up with the exact same thing, right? So this is like an or, right? That's another way that you could solve it, okay? All right, so there's a couple other really neat things about inscribed angles that don't show up with central angles. And one of those really neat things is this idea of overlapping arcs. Okay, so I'm gonna draw. Here's two different inscribed angles. Okay, so there's an angle here and an angle here. Okay, so those are both inscribed angles. Okay, and notice that they intercept the exact same arc. Okay, I genuinely almost tend to think of these as like 2 flashlights or 2 theater lights, because I'm a big theater nerd, like 2 spotlights that are shining on the same location, right? Where you have one spotlight from here and another from here, and then they shine on the same location, right? You can also think of this as like when you go to a movie theater and everybody's looking at the same screen, even though they're in lots of different places in the theater, right? They're all looking at the same spot, okay? So the rule here, because this is my arc, okay, the rule is that the angles that intercept the same arc have to be congruent. Okay, and I'm hoping, like, intuitively that kind of makes sense. If you have 2 angles that are shining on the same spot, right, or like 2 spotlights that are shining on the same spot, then they would have to be equal to each other, right? Otherwise, like if you have one flashlight, for example, that's stronger than another, then it would shine on like a bigger area, right? Okay, so but we have to keep in mind that the rules for inscribed angles still apply. So it's not that if you know the arc, for example, is 50 degrees, then that means both of the angles are 50 degrees. That's not the case because they're inscribed angles. Okay, so I'm going to show you what I mean by that. I've got a couple of examples for you. Okay, so let's say I have this lovely circle. Okay, and then I have, there's one, and then there's a second. Okay, and I'm telling you that this angle right here is 10 degrees, and I want to know what this angle is, and I also would like to know what the arc measurement is. I would also like to know what that arc measurement is. Okay, well, the rule is inscribed angles, if they intersect the same spot, then that means the angles themselves have to be congruent. So since one angle is 10 degrees, that means the other angle has to also be 10 degrees. Okay, and then my rule for inscribed angles is if I want to know what the arc is, I have to do 2 times the angle equals the arc. So that means I end up with y equals 20 degrees. Okay. All right, then I've got one more for you that's kind of working backwards here. Okay, so here's one more circle. Okay, and I have, boom, something like that. There, again, sorry, not drawn very beautifully by me, but I'm going to put the arc that they're intercepting right here. So I'm going to say this angle is x, and this one is y, and I'm going to say that this arc is 48 degrees. Okay, so these are still inscribed angles. So remember, the rule is 2 times the angle equals the arc, or I'm going to use that second equation just so that I don't have to do any solving, right? If I do 1/2 of the arc, that has to equal the angle. And it can be either angle, x or y, because remember, they're going to end up being the same. Okay, and I'm writing it as 1/2 times 48. You can also write it as 48 divided by 2 if you want to, and that's 24 degrees. Okay, so that means both x and y are both 24 degrees. All right. The one other really cool feature, right, or property that kind of is based on inscribed angles is creating inscribed quadrilaterals. Okay, so remember, a quadrilateral is any shape that has 4 sides. Okay, so I'm just going to draw a random one. So I'm going to do a point here, a point here, a point, I don't know, down here, and then a point like up here. So I'm going to label these. Actually, I'm going to connect my dots here. Okay, so this, what I'm drawing on the screen right now, is an inscribed quadrilateral. Okay, we call it inscribed because it is completely inside of the circle. Okay, so I'm going to go ahead and label these, and I'm going to label them in slightly different colors, and you'll see why in a second. So I'm going to label this angle A, this is angle C, and then here's angle B and angle D. Okay, so you can see the rule. I have it written out for you already in this second, this column here right next to the circle. Okay, but the rule is that the opposite angles are supplementary. So my opposite angles I wrote in the same color. So A and C are opposite of each other. Okay, and B and D are opposite of each other. And those angles are supplementary, meaning that they have to add up to 180 degrees. Okay, and this is all based on the rules for inscribed angles. Okay, so kind of neat, right? If you think of, and I'm just going to kind of sketch this out for you all so you can kind of see what this looks like. So if you have a, I'm going to draw it down here on this intersecting chords one. You don't have to draw this. This is just for me to kind of like demonstrate the point that I'm making here. Okay, so say we have this inscribed quadrilateral, right? And we're looking at these two opposite angles here and here. Okay, so that angle here, this angle here, okay, its intercepted arc goes from here to here. Okay, this angle, its intercepted arc goes from here to here. So that's the whole circle, right? The whole circle has 360 degrees in it. And if we go back to our rules for inscribed angles, right, the arc is always double the angles, right? So those two arcs together are 360 degrees. So if I cut that in half, that's going to give me the two angles together, And 360 divided by 2 is 180. So supplementary. Kind of cool, right? Right. So this idea is entirely based on the rules for intercepted and arcs with their inscribed angles. Kind of cool. All right, so I'm going to erase this just so that this doesn't get confusing, right? This was just an example here because I didn't want to muddy up the one that I had already drawn. We'll talk about these last three in another video. Okay, so let's do, I've got one big example for you here. So I'm going to attempt to draw a circle here, and I'm going to draw my inscribed quadrilateral. Okay. Ooh, actually, that looks kind of crazy. Hold on. Okay. Okay, so I'm going to do like to there. We'll go like up here. Again, this is like not drawn to scale at all. You know what? Actually, pause. Give me a second. I need to redraw this because that looks crazy. Give me a sec. Let me pause this and then I'll draw this a little better. Okay, there we go. Now that's drawn a little bit better. So I have my inscribed quadrilateral here. Okay, I have angle A is 85 degrees, angle B is 113 degrees, angle C is 5y, and then angle D is x. Okay, so I know my rule here is that opposite angles are supplementary. Okay, so that means x and 113 are supplementary. So if I add those together, x plus 113, that has to equal 180. And then I'm just going to do minus 113 on both sides. Right, so I end up with x is equal to 67 degrees. Okay, easy peasy, that's it for that one. And the same rule applies for my other set of opposite angles. So the 85 and the 5y together have to add up to 180. So 5y plus 85 has to equal, oops, hold on, that doesn't look like an equal sign. Okay, that has to equal 180. So I'm going to do minus 85 on both sides, minus 85, minus 85. So I get 5y is equal to 95. And then I need to divide that by 5. Okay, right? So when I do that, I end up with y is equal to 19. All right. So that is it for this video. If you are feeling good about these examples, you don't necessarily have to watch the practice problems video, but I do have some practice problems for you on these topics, so the central angles and the inscribed angles. So that is available to you. You can also, though, go on straight to the next notes and examples video, which will be on intersecting chords and secants and tangents. All right, so whichever video you watch next, I'll see you in the next one. Bye, everybody.